When historians describe Niagara Falls in the year 1896, the story they tell is clean, confident, and triumphant. It is presented as the moment humanity finally learned how to tame nature and turn raw force into controlled power. Newspapers of the time called it the dawn of the electrical age. Engineers celebrated it as a victory of science over chaos. At the center of this story stood the world's first large-scale hydroelectric power station, a project so ambitious that it reshaped how cities would function forever. Using alternating current systems perfected by Nikola Tesla and implemented by George Westinghouse, the plant promised to send electricity miles away, powering Buffalo and proving that energy could be transmitted safely over long distances. Above ground, everything looked like progress in its purest form. Massive generators, elegant turbine halls, and carefully planned infrastructure all symbolized a new era. Visitors saw clean architecture, roaring water redirected with precision, and a sense that history itself had turned a corner. This is the version of Niagara Falls that appears in textbooks, documentaries, and museum plaques, a story of innovation, courage, and engineering brilliance. But to build this future, engineers had to do far more than install generators and wires. The project required enormous excavation beneath the falls. Before turbines could spin and electricity could flow, workers needed to carve deep into the earth, cut through bedrock, and create underground chambers strong enough to handle unimaginable forces. These spaces would house turbines, control systems, and access tunnels, all hidden beneath the surface while the spectacle above captured the world's attention. The official records describe this process as routine. Engineers expected solid rock, predictable geology, and perhaps some natural caves shaped by centuries of water erosion. Nothing unusual, nothing remarkable, just the hard but straightforward work of preparing a foundation for modern infrastructure. At first, everything appeared to follow the plan. Crews drilled, blasted, and cleared material exactly where surveys indicated they should. The noise of construction echoed through the gorge as progress continued on schedule. Above ground, journalists wrote glowing reports about the future of electricity, while investors and politicians praised the project as a symbol of American ingenuity. Few people asked questions about what was happening below their feet because there was no reason to. The story felt complete already. Nature was being mastered, and the age of power had arrived. But deep beneath the falls, the excavation began to drift from expectation. As workers pushed past the depths marked on engineering diagrams, they did not encounter untouched bedrock. Instead, their tools broke into empty spaces. Not random voids, not loose caverns carved by water, but structured chambers with defined walls and deliberate shapes. At first, these spaces were dismissed as minor anomalies, perhaps remnants of earlier industrial experiments or misidentified geological features. Yet, as excavation continued, the pattern became harder to ignore. These chambers were deeper than planned, deeper than documented, and deeper than any known construction should have existed. By the time engineers realized the excavation had gone further than intended, something fundamental had shifted. The story of Niagara Falls was no longer just about what was being built above ground. It was about what had already been there, waiting in silence, long before the turbines ever began to turn. The excavation beneath Niagara Falls was supposed to be the most predictable part of the entire project. Engineers had mapped the gorge carefully, studied the limestone and shale layers, and calculated exactly how deep they needed to dig to support the turbines and channels that would harness the river's power. Everything had been measured, planned, and approved. The crews knew what they expected to find, and for the first phase of the work, the ground behaved exactly as anticipated. Rock was cut, debris was removed, and the tunnels expanded steadily downward. The process was loud, slow, and physically demanding, but it followed the logic of engineering manuals and geological surveys. There were no surprises, at least not at first. That changed when drilling past the depth marks indicated on the original plans. Workers noticed that instead of striking dense, continuous bedrock, their tools suddenly broke through into open space. The sensation was unmistakable. Picks no longer met resistance. Drills dropped forward. The echo beneath their feet sounded hollow, not solid. At first, foremen assumed they had encountered a natural cavity, perhaps a pocket carved out by centuries of underground water flow. Niagara was ancient, after all, and the idea of hidden caves did not seem unreasonable. But when lanterns were lowered and workers climbed down to investigate, what they found did not resemble nature at all. The spaces below were not irregular or eroded. They were shaped. The walls were smooth, not fractured. Angles met with consistency. The floors were level. These were not accidental voids formed by water and time. They were chambers. More than that, they were chambers built with intention. The dimensions followed clear proportions. The surfaces showed marks that suggested cutting, not erosion. Even in the dim light of oil lamps, the precision was visible. Engineers quickly realized that these spaces were not part of any known design for the power station, nor did they appear on any historical maps of the area. As excavation continued, more of these chambers appeared. Some connected to narrow passages that extended beyond the immediate construction zone. Others opened into larger vault-like spaces that seemed capable of supporting enormous loads. This raised immediate concerns. If these structures existed, why had they not collapsed over time? And if they were strong enough to remain intact beneath the falls, why were they stronger than anything the project itself required? The deeper the crews went, the clearer it became that this was not a single anomaly. It was a system. Engineers attempted to classify what they were seeing using familiar explanations. Old mill tunnels, abandoned industrial works, forgotten experiments from earlier attempts to harness the river. But none of these explanations fit. The depth was wrong, the scale was wrong, and most troubling of all, the construction methods did not match anything documented in local or regional records. Some conduits appeared embedded directly into the surrounding rock, as if the stone had been shaped around them rather than cut away later. Others extended far beyond where any 19th century project would have needed to go. Quietly, among themselves, engineers began to acknowledge a growing problem. The excavation had not simply uncovered something unexpected. It had gone too deep, not just physically, but historically. Whatever lay beneath Niagara Falls did not belong to the story they thought they were building, and once uncovered, it could not easily be ignored. As engineers continued to document the chambers uncovered beneath Niagara Falls, the problem shifted from unexpected space to unexpected technology. These were no longer just oddly shaped rooms or misplaced tunnels. The deeper sections revealed features that simply did not belong in the year 1896. The materials, the construction methods, and the apparent purpose of the infrastructure conflicted with everything engineers believed they were capable of building at the time. Even those most committed to conventional explanations struggled to make sense of what they were seeing. Some of the chambers were lined with materials that immediately raised questions. Certain walls showed signs of thermal treatment, surfaces layered with ceramic-like compounds designed to withstand extreme heat. This was not decorative, and it was not incidental. These linings resembled insulation systems used in environments where intense energy was generated or transferred. Yet the Niagara project, as officially described, did not require anything close to that level of thermal protection. Water turbines generate mechanical motion, not sustained high temperatures. There was no documented reason for such materials to exist beneath the falls at all. Then there were the cylindrical housings. These massive, symmetrical structures were found embedded within some of the deeper chambers, their surfaces machined with a level of precision that stunned the engineers who examined them. The tolerances were tight, the edges were clean, the shapes were perfectly uniform. In 1896, most industrial components were still produced with visible imperfections, tool marks, and inconsistencies. These housings showed none of that. They looked less like experimental equipment and more like finished products, manufactured to standards that would not become common until decades later. Equally troubling were the conduits running through and between the chambers. These were not simple pipes or channels carved as needed. They followed deliberate paths, angled and positioned with mathematical consistency. Some were embedded directly into the bedrock itself, as if the surrounding stone had been shaped around them rather than cut open to install them later. Others disappeared into darkness beyond the mapped excavation zone, extending far past any area required for turbine operation or maintenance access. No plans explained where they led, and no records acknowledged their existence. Construction photographs from the time, though limited, captured glimpses of this technology. Workers stood beside components so large and precisely formed that they appeared small by comparison. Even in grainy black and white images, the engineering stood out. Modern researchers studying these photographs have noted how closely some of the structures resemble elements of contemporary power systems rather than anything attributed to the late 19th century. Yet in the official documentation, these features were either vaguely labeled or omitted entirely. Privately, some engineers admitted what they could not say publicly. The systems they were uncovering did not resemble American engineering. They did not resemble European designs either. In fact, they did not resemble any known electrical infrastructure at all. These were not failed experiments or abandoned prototypes. They looked purposeful, integrated, and complete, as if they had once formed part of a functioning system whose rules were no longer understood. By this stage, the question was no longer whether the excavation had uncovered something unusual. It was whether the project had exposed technology that did not belong to the historical timeline at all, and that realization would soon change how much of it the world was allowed to see. As the discoveries beneath Niagara Falls became more difficult to explain, something subtle but unmistakable began to change. It did not happen all at once, and it was never announced publicly. Instead, it appeared quietly in the paperwork. Early excavation reports had been detailed, precise, and technical, filled with measurements, diagrams, and careful observations. Engineers were trained to document everything, especially when constructing a project of this scale. But as the deeper chambers were exposed, the language in those reports began to shift. Descriptions grew shorter, technical detail faded. What had once been carefully drawn was now summarized with vague phrases and broad labels. Some of the deepest chambers simply stopped appearing in official blueprints altogether. Early drafts showed extensive underground layouts, while later versions removed entire sections without explanation. Areas that construction photographs clearly captured were reduced to simple annotations such as earlier construction or geological irregularities. These labels were strange because the photographs themselves showed clean angles, uniform surfaces, and unmistakable signs of deliberate engineering. Yet the written records treated them as if they required no further discussion. The photographs themselves tell another story. During the initial stages of excavation, images were taken freely. Workers posed beside tunnel walls, machinery, and newly opened spaces, providing scale and context. But as the discoveries became more advanced, the photographic record narrowed. Wide shots disappeared. Images focused on workers rather than structures. In some cases, photographs that clearly existed according to inventory lists were never included in final project archives. Instead, they surfaced years later in private engineering collections, disconnected from the official narrative of the power station. Then came the ceiling. Sections of the excavation were abruptly filled back in. Passages that had just been opened were packed with rubble and sealed behind new construction. The official explanation cited structural safety and the need to meet construction deadlines. Supporting turbines above required stability, and engineers could not risk collapse. On the surface, this sounded reasonable, but the pattern of what was sealed first raised uncomfortable questions. The areas buried most quickly were not unstable caverns or fractured rock. They were the most precisely engineered chambers, the ones containing unfamiliar materials, unusual housings, and integrated conduits. Equally telling was what remained accessible. Standard geological features and ordinary construction tunnels were left open, documented thoroughly, and incorporated into the final design. It was only the anomalous structures that vanished behind concrete and fill. The excavation itself did not conclude naturally. It stopped, not because the work was finished, but because certain areas were no longer being explored at all. By the time the power station opened and electricity began flowing, the official story was already set. Niagara Falls had been conquered by modern engineering. Any irregularities beneath the surface had been simplified, absorbed, or erased from the record. Engineers who had seen the deeper chambers moved on to other projects. Their private notes were never published. Their questions were never answered. What remains today is a silence that feels deliberate, a gap between what was found and what was acknowledged, Because if nothing unusual existed beneath Niagara Falls, there would have been no need to bury it twice. And if the discoveries truly fit within accepted history, there would have been no reason to stop talking about them at all. By the time construction at Niagara Falls was completed, the ground beneath the turbines had gone quiet again. The chambers were sealed, the passages filled, and the machinery above began doing exactly what history remembers it for. Electricity flowed outward, cities lit up, and the story of modern power moved forward without hesitation. But the questions raised during excavation never truly disappeared. They were simply buried along with the structures that caused them. And once the surface returned to normal, it became easier to pretend that nothing unusual had ever been uncovered at all. Yet when the fragments that remain are examined together, a pattern begins to emerge. The buried chambers were not isolated curiosities, they were integrated, their conduits aligned, their materials were consistent. The deeper the excavation went, the more it suggested that the infrastructure beneath Niagara Falls had not been placed randomly or hastily. It appeared planned, deliberate, and capable of handling forces far beyond what the 1,896 power station would ever generate. This raises a difficult possibility. Perhaps the engineers of the electrical age were not building entirely from scratch. Perhaps they were adapting, repurposing, or unknowingly inheriting something already there. Niagara Falls occupies a unique position geographically. It is a natural concentration of energy, water, and movement, a place that civilizations across time would naturally be drawn to. If a technologically capable society had once existed, seeking locations to generate or distribute power, Niagara would have been an obvious choice. The buried vaults, conduits, and chambers suggest not experimentation, but functionality. Systems designed to operate, not merely to exist. And if that is the case, then the power station built in 1896 may represent not the beginning of electrical infrastructure at Niagara, but its latest layer. What makes this idea more unsettling is how closely it mirrors discoveries elsewhere. Other cities, other rebuilding projects, other moments when excavation went deeper than expected have produced similar accounts. Advanced structures, missing records, sudden sealing. In each case, the surface narrative celebrates progress, while the underground story fades into obscurity. Niagara fits that pattern too neatly to dismiss. The most important question is not whether the buried infrastructure still exists. Much of it almost certainly does. Sealing does not erase structures, it only hides them. The real question is why exploration stopped when it did, why the most advanced chambers were the first to vanish, why official records simplified what photographs clearly showed was complex, and why no serious effort was ever made to explain what those systems were designed to do. Perhaps the answer lies not in what was discovered, but in what acknowledging it would imply. If the foundations of one of the world's most famous power stations rest on technology that predates the electrical age, then the timeline we rely on begins to fracture. Progress no longer looks linear, innovation no longer appears isolated, and modern engineering begins to resemble rediscovery as much as invention. Niagara Falls still roars today, its energy harnessed and measured, its history neatly packaged. But beneath the turbines and tunnels, beneath the concrete and rock, something else may still remain. Silent, intact, waiting. Because if one hidden system was found and sealed beneath the falls, then the real mystery is not what was buried there in 1896. It is how many other places around the world were quietly built on top of something older, and why we were never meant to look too closely beneath the surface.